Weicheng Wang, and this semester I did a project about object detection algorithm, and I experiment with different implementation. First, let's look at the background. The object detection algorithm have two main methods. First one is two-stage, which is also called region-based. It first calculate regions of bounding box. So it's like the candidate of the size of the object, and then a classifier is used to detect within each bounding box to know which object it belongs to. It is slow, but it's very accurate. The popular models contains RCNN and mask RCNN. And the second one is a one-stage algorithm. It skips the region proposal stage and run the detection directly over the whole image. It is fast, but has more errors. The examples contains YOLO family and SSD. I mentioned them in my papers. So this semester, I mainly worked on YOLO v3. The YOLO family is one-stage object detection algorithm. But YOLO v3 is based on YOLO v1 and YOLO v2. The main idea is it first splits the image into several grid cells, and each cell has responsibility to detect the center of the object, and at the same time it will generate the size of the object, and also with a confidence. And it is the main idea of YOLO, and YOLO v3 has some modifications, and I don't have time to talk about them in details. So this semester I implement on different versions of YOLO v3. First is the original one. It's based on Eric's implementation. I tested with different parameters like different training data, testing data, and different backbones. Also, I tried with YOLO Tiny and YOLO Lite. Those two are used to use the smaller models, which reduce the several layers, and YOLO Lite even reduced the backbones. And also, I tried with model pruning. The idea of model pruning is to reduce the size of model. It's after the training. The idea is general, but it's not only for the YOLO, but I use it to test. Okay, let's look at the evaluation. First, the different versions of YOLO. If you look at the example, if I tried with good backbones, I will get good accuracy, but at the same time, the size of the model will be bigger. And looking at the different objects, you can see some examples like cats. It has a very high accuracy. Maybe there are more samples in the training data, but some very big objects like boat, the accuracy is not that good. So even within a training set, the performance is different from object to object. Also, look at the pruning result. You can see the accuracy is almost the average accuracy is almost the same, but the size of the model reduced a lot. So it's a good try. Okay, to summarize this semester's work, I first summarize 3 algorithm paper and mask RCNN SSD and YOLO, and I experiment on different versions of YOLO based on Eric's code. The algorithm is fast but not good enough to my mind. For example, the chairs are not detected very well in this picture, and in the future we can have better improvement of the accuracy, and also we can try with different data set like in biology or civilization. I can try with different data set to test different kinds of algorithms. Thank you. That's what I did this semester.